The difference between an experiment and an observational study is relatively small, but it is what determines whether or not we can declare cause and effect. So it might seem small at a glance, but it is actually a very big deal. When you are considering an experiment, the people who are conducting the experiment, the researchers, are allowed to manipulate or control something. Now, when I say manipulate, I don't mean they're manipulating the results and they're scheming together, they're ready to make sure that whatever results they find fits their narrative. No, when I say they manipulate something, I mean they have control or an influence over typically one or two, maybe more than that, aspects of the experiment. So picture a room of people, and there's 100 people that are randomly split up into two groups. One group takes a placebo, and the other group takes an actual medication that they're trying to see whether it has an influence on their symptoms. That is an experiment. They could also control other things. Maybe they want to see what effect chewing gum has on people's jaw strength, and they have one group that chews gum once a day, and another group that chews gum for at least an hour a day. Kind of a weird experiment, but an experiment all the same, because they are manipulating or controlling something. In an observational study, the researchers are limited to observing. They might ask some questions, they might take some measurements, but nothing that they do influences the results like it would if it was an experiment. So if you have a group of 100 people, and you ask everybody, do you smoke or do you not smoke? And after you ask that question, you prick their finger and measure something in the blood. That is an observational study. Now, I got stuck here when I was first learning because in my head, pricking the blood, taking those measurements, that's something you do in a lab, therefore it's an experiment. Not quite. You see, they took those measurements to measure the blood as it was. They had no influence on what type of blood they were measuring. They had no influence on, okay, only people who smoke were going to test the blood. It was straight up, ask the question, measure what they came in with. If it was something a little different, if say they asked people not to smoke before they came in or to limit what they smoke, and then they ask some of the other people to smoke extra, then you're heading into the realm of experiment because they're influencing what people's blood is going to say on the results. Or they are influencing what the answers are going to be. They're doing something that affects it in some way. But if all they're doing is asking yes or no and then pricking the finger to measure as it's presented, that is an observational study. In both experiments and observational studies, you have researchers and subjects, but in only one of those are the researchers allowed to manipulate something. And that is where that small difference becomes a very big thing, because that difference determines whether or not we can declare cause and effect. We can only declare cause and effect based off of the results of an experiment, not an observational study. So let's say we're running an experiment and we have 100 people who are presenting with bad migraine symptoms. They have migraines every single day. And we decide for the duration of the experiment that half of the group is going to be getting a placebo and the other half is going to be getting this fancy schmancy new medicine that's supposed to take away migraines. At the end of the experiment, the people who took the placebo report that they have 0 to 2 days a week with no migraines, whereas the group that took the medicine is reporting 4 to 5 days a week with no migraines. At the end of this experiment, we can then conclude that this medicine is helping to reduce the amount of migraines that subjects face. Now, a quick note, 100 people is a very small study. You're probably going to want a little more than that, but you get the gist of it. We can determine, based off of our experiment, the cause and effect. Now let's go back to the 100 smokers versus non-smokers. Let's say that by some miracle, this randomly selected group has a perfect 50-50 split. 50 of them do not smoke, 50 of them do smoke. After we prick their fingers, we discover that out of the 50 people who don't smoke, only 2 of them have diabetes. Whereas out of the 50 people who do smoke, there is 23 people with diabetes. We might look at those results and think, wow, smoking is causing diabetes. But we can't actually say that because this was only an observational study, not an experiment. Now, this might trigger us to do an experiment because getting that many people with diabetes who smoke might raise some flags, but we don't know anything else about these people. We didn't have any sort of, we're doing this experiment for a year, we need you to smoke this many this week, this many this next week. We haven't looked at the family history. We haven't done anything except for observe. So we cannot declare cause and effect. That is the difference between an experiment and an observational study. And only after an experiment can we declare cause and effect. So the next time your professor asks the class, is this an experiment or an observational study, you should be the first one raising your hand. Good luck with your studies and have a great day.